Okay, they want to know which A, B, C, and D are equivalent to. So equations are equivalent when they have the same solution set, right? So let's solve this, right? Let's see what that is. So I'm going to distribute. I'm going to get 12x minus 4 plus 3x equals 9x plus 5. And then combine like terms. 15x minus 4 equals 9x plus 5. Subtract 9x, that's 6x minus 4 equals 5. Add 4, 6x equals 9. X equals 9 6. So x equals 3 halves. So there's the solution, right? Now, a couple ways I could do it. I could substitute 3 halves into all these equations, or I could just solve them. Let's just solve them, right? So A, 12x minus 4 plus 3x equals 9x plus 5. 15x minus 4 equals 9x plus 5. Subtract 9x. 6x minus 4 equals 5. 6x equals 9, x equals 9 sixths, which is 3 halves. Okay, so A works, right? A is equivalent. Now let me make some space. I'm going to do them all right here, right? Okay, let's do B now, right? B. So B, we have 12x minus 1 plus 3x equals 9x plus 5. 12x and 3x is 15x minus 1 equals 9x plus 5. Subtract 9x, 6x minus 1 equals 5. Add 1, 6x equals 6, x equals 1. So B is not equivalent, right? Clearly not equivalent. Okay, next one. So I'm not going to circle B. And the reason I'm going on is because it didn't say there was only one, so we have to check. So C, 11x equals 14x. Well, clearly this isn't going to work, right? So we have 0 equals 3x, 0 equals x. So that clearly doesn't work, right? X is not 0, right? And let's do D. So D, 15x minus 4 equals 9x plus 5. Subtract 9x, we get 6x minus 4 equals 5. 6x equals 9, x equals 9 sixths, so therefore x equals 3 halves. That's right. So A and D are both equivalent.